Hi, I'm Sam Helmuth and I'm presenting this video on behalf of myself and Obaid Al-Aqlabi, who I hope will be joining us at MFM. Our poster is about using L2 production and perception behavioral evidence as a diagnostic for properties of the phonology of the L1 of the speakers. The language we're talking about is Arabic, two different spoken dialects of Arabic. We have a main story and an interesting subplot, and we hope you'll come for both of those. The main story is that Nancy Hall proposes a distinction between epenthetic, fully phonological vowels and intrusive vowels, which are phonetic transitions between consonantal gestures. And in L1 production data, we show that word medial three consonant clusters are broken up with epenthetic vowels, but word initial onset clusters are broken up with intrusive vowels. And you can hear the detail when you come and see us. In L2 production and perception in English, you might expect that the learners of English would have difficulty with clusters if they break them up in their L1. But in fact, they don't. They're really good at word initial clusters, so onset clusters, but they have problems with word medial ones. And we think that is a really nice reflection of the phonology of the L1 from the production data. And the perception data parallels that completely. It's really neat and beautiful. The subplot is something about the onset coda cluster asymmetry, and you'll have to come to the poster to hear about that.
Hello, so our poster is about the multiple phonologies of English. English phonology is often treated as a uniform system, and it's common practice to give borrowings as examples of English stress rules. For example, the word monongahela is found in countless works on secondary stress placement. Following Carney, who works on the relationship between spelling and sound, we assume that there are different lexical subsystems, and that each of these subsystems has its own set of phonological, morphological, semantic, graphophonological, and segmental characteristics. And we identify these characteristics based on available evidence from various sources, many of which have worked using dictionary data. So we present the general system that we are assuming that you can see here. And we can see that this system is made of different parts which partly overlap. We also discuss evidence showing that the behavior that we observe in speakers resembles the one that we find in dictionaries. And we also discuss the fact that borrowings often reproduce the patterns that are found in source languages. For example, they reproduce the position of stress, but that when they diverge from these patterns, it's often to adopt the pattern of the corresponding subsystem in English. We finish by presenting a series of testable predictions that we can make from our model. And the general take-home message is that when we are conducting nonce word experiments with English speakers, it's really important to control for these subsystems, especially when we're using stimuli that are written, because the stimuli might contain cues that lead speakers to use the phonological system of a specific subsystem, and maybe not the core system that we're maybe aiming for.
Hi everyone, I'm Paolo Danesi and I'm a PhD student at University Côte d'Azur in Nice. Today I will discuss the case of Camuno, an Eastern Lombard dialect that is spoken in northern Italy that exhibits a regressive, raising vowel harmony that is parasitic on rounding. Pretonic rounded vowel raise whenever they are followed by any stressed high vowel. Pretonic non-rounded vowels, on the other hand, raise only if they are followed by a stressed E, and remain mid otherwise. Very few approaches analyze parasitic vowel harmony, and to my knowledge, all of them do so stipulating a requirement on feature identity of some sort. Strategies of this kind fail to understand why vowel harmonies are parasitic and simply restate the descriptive facts. Here I will compare two different approaches that deal with parasitic vowel harmony. Both of them utilize emergent features and belong to the theoretical framework of substance-free phonology. Emergent features are learned categories that don't have a fixed correlation with phonetics. Speakers learn features on the basis of contrast and phonological alternations. The approaches presented here are different mainly in the way they conceive and formalize feature learning. In the first one, contrast and phonological alternation inform the learner simultaneously. Representations are required to be maximally parsimonious, meaning that features are learned only if they are contrastive. Their contrastive role is ensured by the application of the successive division algorithm that guarantees that only contrastive features are learned. This algorithm creates a hierarchic structure that affects the way segments behave in phonological processing. Hierarchical relations between features allow to predict parasitic applications of vowel harmony. In the second one, phonological alternation have a logical precedence over contrast during feature learning. In this case, a learner exposed to a language with a parasitic vowel harmony, such as Camuno, will deduce the existence of two different harmonic patterns that involve the spreading of two different substance-free features. If you want to know more, please come and take a look at my poster.
Hi, in Mohannius Unitario, there is syncope of every odd syllable except for the final vowel. You can see that in the first two examples. In a smaller group of words, there is syncope of every even syllable, as in the second two examples. Now, this has been analyzed in a Moraic analysis by Rose in 2019, and she says that the language has two parses, an iambic parse, in which the final syllable or the final foot remain unparsed because there is non-finality, and a trochaic parse, where there's a possible non-finality effect of the syllable, but not obligatory. Now, I think this is not a good analysis because it has several problems. There's two different motivations for syncope, as I will show. First, a vowel in a weak position or an unfooted vowel. Second, there is this exemption of the final vowel for no apparent reason. Third, there's iambic and trochaic parses in the same language. Fourth, there is non-finality. Do we really need non-finality at all or in this language? And finally, there's variable non-finality. It depends really on the parse, so it's not like a requirement of the system. So what I propose is to look at it from the angle of strict CV metrics with the tool of incorporation. In incorporation, whereas every vowel projects to the same level initially, the projections of some vowels are incorporated into those of an adjacent vowel, in this case to the right. And once that happens, the vowel that does not project cannot be realized, so it's syncopated. I will show that in this approach, there's only one reason for syncope. There's no such thing as unparsedness. The exceptionality of the rightmost vowel comes for free, and the trochaic parse can be regarded as the same thing as the iambic parse plus an initial freestanding projection. I will also show that other segmental effects follow more straightforwardly from my account than from the previous one.
Hi, I'm Zirgamon. This is work in collaboration with Chao Zhou from the University of Lisbon on the acquisition of the Portuguese tab by Mandarin learners. And previous studies showed that learners replace this tab in onset position by the lateral, whereas in the coda position, it's replaced by all kinds of segments, amongst them the retroflex rotate typical in Mandarin. In an experimental study, we showed that this replacement is due to orthography. That's the focus of this poster, this prosodic specific orthographic influence. It has been modeled before in bidirectional phonetics and phonology OT by Joe, where he shows that the CV transitions that are very salient determine the output in onset position, whereas in coda position, they are not present, and therefore the next salient information, the orthographic cue, takes over. In our poster, we have a new modeling, namely in bidirectional phonetics neural network. We use symbolic nodes, and the network example is given here, and you can see that we have auditory nodes as input, or an orthographic node, they can be switched on or off. And as output nodes, we have phonological information with position, onset or coda. And the strength of the connections between the different nodes are determined on the basis of Mandarin allophonic categories, the auditory cues, and the pinyin written form. And what's important that in this model, phonotactic restrictions are reflected by connection weights between auditory form and phonological nodes. Right? But for more details, you need to come to our poster. Thank you very much.
Hi, I'm Farhad Jabi, and my poster is about the prosodic realization and the prosodic status of case and discourse markers in Urdu. I looked at 7 case markers and 3 discourse markers. Based on their patterns of assimilation and lexical stress, I showed that these markers form prosodic words on their own. The prosodic realization of these case and discourse markers varies on the basis of their information structure. The data shows that these markers also participate in triggering the rhythm constraint proposed by Jabi and De La Rouserie in their analysis of Urdu intonation. The existing literature shows that these case and discourse markers are clitics morphosyntactically. But my data reported here shows that they are not prosodically deficient. In the end, I offer an analysis of these markers according to Selkirk's prosodic analysis of function words. I look forward to seeing many of you in the poster session. Bye.
Hi everyone, welcome to this brief taster for my poster on clitics and contractions in Galician, where I focus on the definite article, so here the third person singular masculine o. In one we have o pan, the bread, and in one be como o pan, I eat the bread. This is the citation form. And what's been noticed is that the article criticizes onto the preceding preposition or verb, and when that host ends in R or S, then that final RS, descriptively speaking, changes to the lateral L. So in 2 we have comes, you eat, and that does not become comes o pan, it becomes comelo pan. We have similarly for 3, for the infinitive, comer becomes comelo pan. So a few questions have already been discussed in the formal literature. Do we have cases of allomorphia of the article? Is this some case of opacity where we have a change triggered and then something on the host deleting? And what I want to say in this poster is that we can get a better understanding of what's going on with the definite article and with the system in general by contrasting it with the direct object clitic. So I have 3 examples for that. I'll just talk about the first one right now, and you can have a look at the other ones later and come by the poster. The idea is that the direct object clitic is weak and must criticize, but it still shows the same kind of allomorphic patterns as the definite article. So we have prepositions that can criticize onto a determiner, similar to what you might be familiar with from Portuguese. So that's in 4, de aquel of that becomes daquel. And what we see in 5 is that this happens with the article. So pensar en o futuro, think about the future, becomes in 5a pensar no futuro. And we have in 5b contraction with a different the demonstrative, pensar niso. But the direct object clitic is too weak to stand on its own, and it can't criticize onto the preposition, which is weak in and of itself, and that's in C and D. So there are a couple of other differences between the 2 in 6 and 7. So if you want to talk about these, see what they are, and discuss what a formal analysis might mean and what it means for the morphology, phonology, syntax, prosody, lexicon interface, I look forward to seeing you at the poster.
Our poster on Bantu vowel height harmony and ATR harmony provides an explanation why these 2 types of vowel harmony contrast in their domains of application and directionality. Both processes are very well known in the literature, but there is no current unified analysis that explains their contrastive behavior. Vowel height harmony is found in some 5 and 7 vowel languages and applies from verb roots to suffixes and is in this sense more restricted in directionality, being from left to right only. ATR harmony in languages like Kinandi and Kimatumbi in some 7 and 10 vowel languages is by contrast bidirectional and can be triggered by prefixes, verb roots, and suffixes. We capture this contrast by proposing recursive structures, which on the one hand allow segmental level agreement to capture the more restricted vowel height harmony, but also allows agreement at the prosodic level, where the harmonic element R has scope over the whole complex verb, so that directionality effects seen in ATR harmony are simply an epiphenomenon of this vantage prosodic position. Come along and we will reveal all. Thank you.
In my poster, The German Past Participle Prefix Game, a typological analysis, I use an array of German dialects to explore the morphophonological timing of prefixation within the word formation process of the German past participle. The alternation in past participle shape in German is phonologically conditioned. Root verbs with initial stress, examples A, B, and C in the table, have prefixed surface forms, whereas root verbs without initial stress, example D, lack a prefix. Analyses proposed for Standard German hinge upon the question of the underlying form of the past participle. Is it underlyingly prefixed, with prefix deletion operating as phonological optimization, or vice versa? Data from Standard German are insufficient to allow us to reject either analysis. Thus, I implore Bavarian dialects, more specifically to Southern and one Central Bavarian variety, to provide a more heterogeneous picture. In the observed dialects, the past participle prefix for stressed initial verbs takes three different surface forms: a CV syllable, the first consonant of an onsets cluster, or an L segment. Inter- and intradialectal variation is caused by dialect-specific phonotactic constraints and faithfulness to the underlying template rather than rhythmic considerations. As the surface prefix forms in Bavarian dialects are not consistently syllabic, it is unlikely the prefixation serves as a late-stage repair for metric structure as proposed for Standard German. At the same time, Bavarian dialects retain the generalization that root verbs without initial stress surface in unprefixed form, even if the CC cluster resulting from prefixation is listed in the target dialect, necessitating the involvement of a stress-based element in the analysis. If you're interested in hearing more about the dialectal data or my analysis of them, visit my poster.
Hello, we'd like to show you an interesting difference between nominal and verbal morphology in Hungarian. We compare nominal diminutives and verbal frequentatives. Nominal diminutives and verbal frequentatives may be formed in the default agglutinative morphology, but this is not our concern here. There are also diminutive and frequentative forms that display templatic patterns. These word forms fit into a disyllabic template. Furthermore, the suffixes applied in this template fail to harmonize, unlike agglutinative suffixes, which normally have a front and back voweled allomorph selected according to the stem vowels.
There are phonotactic differences between nouns and verbs. For instance, nouns exhibit much more disharmony than verbs. Thus, the vowels in verbs are more harmonic. Furthermore, a nominal stem may undergo truncation and a verbal stem may not. As a result, since the harmonically invariant verbal templatic frequentative suffixes contain a back vowel, this type of frequentative formation is defective, and it's limited to monosyllabic back voweled roots. A frequentative form based on a polysyllabic root would violate the disyllabicity of the template. A front voweled one would violate the ban on disharmony in verbs. Harmonically invariant nominal templatic diminutives, however, allow massive truncation and disharmony, and thus avoid defectiveness.
The difference between templatic frequentatives and diminutives is manifested in radically different productivity between verbal and nominal templatic morphology. Verbal frequentatives of this kind are lexically limited to a closed set. Only monosyllabic back vowel stems can have such a frequentative form. On the other hand, nominal diminutives are not constrained in this way.
For further details, come and check out our poster.
Hi everyone, this is Dilshah Samish from Boğaziçi University and I'll be talking about high vowel shortening in Turkish. So High vowel shortening is well documented in a number of languages such as Northern Greek, Japanese, Korean, and Uzbek, another Turkic language, among others. And in those languages, in most of these languages, this process is thought to be purely phonetic. But in some other languages, that is not the case. In those languages, it is thought to be at least partly governed by phonology. So what we want to do here today is to find out whether this process is also purely phonetic in Turkish or if it is controlled by semi-categorical processes, phonological processes. So we conducted 2 experiments with 18 native speakers of Turkish, and our experimental observations suggest that high vowel shortening is an allophonic rule controlled by phonology in Turkish. So as I said, we conducted 2 experiments, one with 4 native speakers, the second with 14, and we had different conditions, items, and environments in both of these experiments, and in total we examined about 5,000 tokens. If shortening were phonetic in Turkish, what we would expect to find is that what matters would be the actual position of the tongue and not the vowel's phonological category. And if shortening were phonological, it would be the exact opposite. So what matters would be the phonological category of the vowel and not the actual position of the tongue. So when it comes to the results, you can see here in this table that high vowels are shown in red, while the non-high vowels are shown in dark blue. And non-high vowels averaged at around 58 milliseconds, while the high vowels average at around 35 milliseconds. So already you see that there's a big difference in duration between high and non-high vowels. And here you can see that in the graph form. So again, the dark blue shows the non-high vowels, red shows the high vowels, and y-axis is the duration. So the reds, meaning the high vowels, are almost always shorter than the non-high vowels. So when it comes to conclusion, our data shows that in Turkish, high vowels are indeed shorter than non-high vowels, and this process is not purely phonetic. It is at least partly governed by phonology. Our data confirms also that the boundary between phonetics and phonology is language specific, and even processes that start with a purely phonetic motivation may be phonologized down the line. Thank you.
Hi, my name is Pamela Sugru. I'm going to be talking today about some research that I've conducted on Irish and a morphophonological phenomenon found in it and other Celtic languages called mutation. The question that I'm addressing in this research is whether variation in Irish mutation is rightly ascribed to speaker disfluency and language decline. As you can see here in the bottom in this literature review, in the past, many analyses of Irish have attributed any variation in this mutation process to language decline or death. Variation here is any deviance from the official standard grammar, the rules that are codified therein about when to apply and when not to apply mutation and in what fashion. On the other hand, a very similar process in Welsh mutations has been treated very differently in the theoretical literature. So it has been analyzed as subject to, say, lexical frequency effects, initial consonant effects, speech register effects, and so forth, without attributing any variation in Welsh mutations to poor speakership, language decline, and so forth. And so this sort of leads us to hypotheses. The first is the basic variables hypothesis. This says that any variables that aren't codified by the official rules will cause no change in a machine classifier. This would tend to support some historical analyses of Irish, which do not consider other variables, such as the ones we've discussed in the theoretical literature about Welsh. On the other hand, we have this augmented variables hypothesis, which says that information about the variables, such as those that are known to contribute to Welsh mutations, those should improve the performance of a machine classifier if you give it the task of learning from training data human-like patterns of mutation. And ultimately, we found that an augmented variables classifier is significantly better than a basic variables classifier at learning and reproducing human-like patterns of Irish mutation. From this, I argue that Irish mutations have not been shown to represent speaker disfluency or language decline, and actually that they're subject to a host of effects that are as yet not described in the Irish language literature. Thank you.